Hello! Be welcome for a new episode involving the lab color space in Photoshop. In the previous episodes, I presented some practical uses of the lab color space in Photoshop. Now, hoping to make lab space easier to understand and use, I'll deal here some less known issues about color setting in lab mode. Lab space is larger than the gamut of the devices such as computer displays and printers, exceeds the gamuts of the RGB and CMYK color modes, and even falls outside the human vision. Moreover, a significant part of the lab color space coordinates cannot simulate the spectral distribution. In other words, these values do not represent true colors, so they are impossible colors. Colors that do not physically exist and cannot be generated by any device, no matter what it is: monitor, laser, inkjet, or anything else. To clarify how these particularities affect the colors setting in Photoshop lab mode, let's start a few experiments. Start Photoshop and open the color panel. Activate lab sliders. As can be seen, the lab has a completely different structure from RGB and CMYK. L is luminance. It ranges between 0 and 100. A is a color scale ranging from -128 to +127. Negative values represent tones of green. Positive values, tones of magenta. B is a color scale ranging also from -128 to +127. Negative values represent tones of blue and positive values are tones of yellow. As you can remark, the negative values represent cool tones while positive values represent warm tones. Values 0 for A and B are neutral gray. Let's find the middle gray lab value. Of course, set A and B to 0 because it's perfectly neutral. For luminance, it seems logical to presume it is the middle of the scale, halfway between 0 and 100, that is 50. To see the RGB response of this presumed lab middle gray, click the foreground icon to activate the color picker. If you expect to see 128 for all RGB values, 50% gray, you could be surprised. Here is 119. It's not a mistake, Photoshop works well. In reverse, set all RGB values to 128. Lab response for luminance is 54. That's because lab was designed to model the human perception of light, not to represent colors of an RGB monitor or ink colors. Human vision distinguishes more lightness values in darker ranges than in lighter ones. That's why the lab color mode reserves more values for the darker area. That explains the higher value for lab middle gray. What happens at the ends of the L scale? If luminance is 0, we should have black. Black is neutral, so A and B must be 0 too. As expected, RGB response is pure black. Now, if we set A to any negative value and B to any positive value, RGB response is always the same. It's perfectly normal. 0 luminance means total darkness and should be perceived as black. Conclusion: any such combination in lab space represents an impossible color. While translates such color to RGB, Photoshop ignores any A negative value and any B positive value, refers only to the null L value and returns RGB black. Let's keep 0 value for L and set A to a positive value and B to a negative value. Such combinations also represent impossible colors. But here the situation is turning into a more confusing one. Despite this L0, you don't get black at all. The response is a color. The same happens if A and B are both negative or both positive. Photoshop returns RGB values that converted back to lab provides a non-zero value for luminance. Moving to the other extremity of the luminance scale, L100, we'll find other impossibilities. In the lab space, the luminosity and the color are strictly separated. That is, any luminance values is applied equally to all colors. Therefore, we can expect that 100 luminance will give white whatever A and B values are. Well, you can see it doesn't happen. On the contrary, the more the A and B are away from zero, the more saturated the color is. Photoshop returns RGB white only for L100, A0 and B0. Any combination L100 and A or B non-zero represents an impossible color. An important conclusion to be retained is that the proximity of the slider to the edges of any of lab scales increases the possibility that the resulting values might represent impossible colors or fall out of RGB or CMYK range. Out of gamut or physically impossible, Photoshop allows us to specify any lab combination within the entire allocated range. What happens when we specify an impossible color or one that falls out of RGB gamut? A few experiments could be useful to get an answer. Let's use lab values from extremities of all scales and try to simulate the primary RGB colors. First, set L to 100, A and B both to 127. Of course, this is an impossible color. While it translates this color to RGB, Photoshop ignores the exact mathematical response and approximates the closest combination that can be found inside the RGB gamut. The highest A and B values, magenta and yellow, are expected to form together red, eventually the primary RGB red at high luminosity. Now activate the color picker. You can see here the RGB response. It's red even if it's not the primary RGB red. But it is enough to reduce L value to 94 and you'll get the RGB primary red. Even more, for any L value between 94 and 45, the result is always the same. Primary red. The very extended lab gamut allows Photoshop using many lab combinations to simulate the same valid RGB color. Only one of these is the precise mathematical lab response. To get it, reverse the procedure and first set the targeted RGB value. As you can see, the lab response for the RGB primary red color is this combination of values, each of them placed quite far from the extremities of its scale. Now, if you reproduce this experiment on your computer, you may see other values than those here. Why could this happen? When converting color values from one mode to another, Photoshop uses the information displayed in the color settings dialog box. If your settings differ from my settings here, it's expected the conversion values to be different too. Just for fun, you can try to simulate any other primary or even secondary RGB color starting from various combinations of the values placed at the extremities of the lab scales. That can be useful to understand better how Photoshop works in lab color mode. That's all for today's episode. I hope it is useful for you. If you liked it, click the like button and share this video with your friends. Please subscribe to this channel if you haven't already. Ring the bell to get notified about the future episodes. If you have any comments and questions, leave them in the section below. I will be glad to answer promptly.